in this video we're going to do a little bit of synthetic division, okay, which can be a really great, efficient way to find out if a binomial factor, is a factor of a higher order function. So here's a cubic expression, and again I'm going to look at that last term and figure I got to do some multiple of or some factor of negative 24. So how you start this is you need to have every place held, and all you need is the coefficients. Okay. So no variables, and then I'm going to put this upside down division thing, and let's say I want to find out first about x minus 6. Now I'm going to choose the opposite because I want to find out if 6 is a root. I'm going to put the 6 here. Okay, how we do this is carry down the 2, multiply. 6 times 2 is 12. Add negative 18 and 12 is negative 6. Multiply. 6 times negative 6. Add positive 4. Multiply. 6 times 4. And look at that. I get a 0. If I get a 0, that means that in fact x minus 6 is a factor of 2x cubed minus 18x squared plus 40x minus 24. And in fact, these are the coefficients of its other factor, of the quadratic factor that it goes with. So I have x minus 6 times 2x squared minus 6x plus 4. Okay? And depending on your aptitude with factoring, you should right away see that there's a 2 across here. Well, there was a 2 at the beginning, but here we've got, so let's pull the 2 out. We got 2 times x minus 6 times x squared minus 3x plus 2. And we look at that. This is factorable in and of itself very quickly. So 2 times x minus 6 times x minus 2 times x minus 1. Because this pair of binomial factors certainly multiplies to make this quadratic. Now we could easily go back and check 2 and 1, and it should work out the same. Let's go ahead and do that. So just because I want you to see how this works, okay? So let's try 2 for this x minus 2 down here. Oops, there it is, down here. Okay. So again, we carry the 2, multiply. 4, negative 14, multiply, negative 28. Add 12, multiply. 2 times 12 is 24. 0. Sure enough, it does. It works. So it's a very quick way to test the divisibility of a potential root of a higher order function. Now let's take a look at another one. Now this one, if you've got any practice at this at all, you should see that there's not only an x in both these terms, but there's a 5. So if we factored this, we'd get 5x times x squared minus 36, which, you know, again is a difference of 2 squares. So it's x plus 6 times x minus 6, okay? But what happens if you weren't sure? Or let's say we wanted to test our synthetic division skills, and we want to see if negative 6 or 6 will work. Okay, can I just put in 5 and negative 180? It won't work if I do that, okay? You need placeholders, so you have to have a 0. If I can find my spot here, whoops. So we're going to have a 5 for the 5x cubed. We have no x squared terms. Then we have a negative 180. And we have no constant term. So now let's try my 6. And we carry the 5 down. 6 times 5 is 30. 0 plus 30 is 30. 6 times 30 is 180. 180 and 0 is 0, and I didn't need this one, but I put it in there anyway as a placeholder. So in fact, you know, you can see right off the bat that in fact x minus 6 based on this 6 times 5x cubed 5x squared plus 30x plus 0, but still works. And again, then you factor out the 5x, and guess what you get? 5x times x plus 6, and you got the same way. So synthetic division, really efficient, takes a little practice.